Okay, so good evening and welcome to this first meeting which we are having online to describe this hackathon. We want to only keep this meeting very short, and so let's go ahead without further delay. Let me share my screen with you. So, what is this hackathon all about? What is this MIDAS software? So, basically, if you are looking at the software, it is a software that is essentially going to do some physics for us. What is the physics? So, for example, let us say that you are going to have a tug of war with somebody. So, tug of war where you are having a rope and you are pulling the rope across. Pardon my drawing, I'm not really the best of persons for doing the drawing. So suppose this rope is being pulled, and this is what we call as the mean position or the equilibrium position. So when the rope is being pulled, if we find that the position is the same, it means both the people are pulling the rope with the same force. Let us say that this person is pulling with 10 kilogram force, very small force, small children are only pulling, and this person is also pulling with 10 kilogram. There is going to be what is known as equilibrium. Essentially, whatever we do, we are trying to achieve the equilibrium condition in buildings or bridges or anything. Very simple example which I always like to give is, let us take that there is a ditch over here which is under construction or which has been constructed. You will always find that you will need to keep a plank of some sort to ensure that you are safely able to cross across. Okay, forgive me for the horrible drawing. Anyway, I'm not going to redo it. So suppose a person is going to stand over here. They are essentially giving a weight. So suppose the person is 60 kilograms. So when the person is 60 kilograms, and let us say that that person is standing right at the middle of the bridge, or this plank is there, and you're trying to make it, you're going to make sure that the plank is going to take the load. This is what we see in all the bridges or other places. Very quickly, let me just show you a very short video. So watch this. If you see, this bridge is essentially like a plank. It is just a plank. It is sitting on a middle support and on the two sides. And instead of a person standing, we are having cars and other vehicles moving around. So basically, what we are trying to do with software like MIDAS is, we are trying to ensure that the load which is coming on the bridging element, we want to make sure that it reaches the ends safely. So essentially, suppose it is in the middle, automatically you'll say that here there's a 30 kilogram force, and over here there is another 30 kilogram force. So basically, whenever we are having any of these software tools, especially which you're talking about in civil engineering, we are only trying to find whether the what is the force which is going to be present in different parts uh, of the element which you are considering. Okay, so this can be like a roof of the building being rested on beams, or next time you go to your classroom, you'll observe that there are beams and a slab is sitting on it. So something arrangement of that is what we are looking at. Let us say that you would have studied the principle of levers, and that is what we use a lot here in, right. So suppose this is supposed to be a straight line, guys. Suppose I'm going to have a system here. If suppose the load is right in the middle, automatically we'll say that the load is equally divided on both the sides. And if suppose we are not having the load equally present, let us say that we are having a small lever. Okay, so here there is the fulcrum. So we know that the load into load arm is equal to effort into effort arm. Automatically, you'll say that a small value of force will be able to take a large value of force over here. So basically, what we are doing is we are trying to take the rotations of the forces. Over here, I am finding that if suppose over here, I mean the beam over here, there are vertical forces. The sum of all the vertical forces should be 0. Okay, and this is what we call as equilibrium. In the same way, this force is causing this lever to turn. Okay, so this is what we would have studied as moment. This is what we call as moment. Okay, and here there is a force. Essentially, this is like trying to cut it across. So in civil engineering terms, we call it as shear force. Now, where is this shear force? This shear force will be acting at every section of this beam. In the same way, you'll find that there is a rotation which is happening because of the action of the forces, and we don't want that rotation to take place. So whatever is F into X, it should be equal to small f into Y. If that is satisfied, then the element doesn't rotate. Okay, so that it is that simple. Essentially, you are going to get a series of equations, and you are going to try to make the element or whatever is the when I say element, it is the load bearing system which takes the load and ensures that it is resting safely. Okay, so it is only going to, this software is only going to find these values. Okay, this is going to find, this software is only going to find these values. Okay, but it is not as simple as what I'm putting it, because when you look at a beam which is bridging across a gap, you don't want it to be having too much of deflection. That means you don't want the beam to bend so much that it's going to cause anybody who's using it to feel uncomfortable. So if suppose there is a bridge over here, you don't want it to bend so much, okay, because of a load. Of course, if the beam is bending, it doesn't mean it is unsafe, but then it isn't going to cause comfort to the people. So when you are looking at a structure like Burj Khalifa, you can imagine how much forces are going to be there. It is going to be an amazingly difficult system to think of also. If you look at places where it's snowing and other things, you'll find that the snow itself is causing a lot of load. And of course, when there is a thermal change, what happens to a body? So when you look at the MIDAS interface, you'll find that there are a lot of different types of ways by which we are going to do the analysis. Analysis is nothing but finding how much force is there in different places. We have actually understood that what we are going to do in this is nothing but a very simple physics which we have already done. And essentially, if you look at the structures work, is suppose we are just having a thin plate, it just falls off. The same thing, if suppose we are going to bend it, okay, if you're going to bend it, you'll find that it is becoming much stronger. Okay, and you'll be able to bridge the distance comfortably. Same paper, I just changed the shape. Okay, so you will find that these are some of the parameters which are being dealt with whenever you are dealing with the software, and we are going to introduce these terms to you. So like for example, what I essentially did over here is I increased the moment of inertia of the section. So if I'm going to increase the depth, you'll find that it is going to bridge a longer distance. Again, I can change the property of the material. I can, instead of using a sheet of paper, I could use a sheet of metal. The value of E, or Young's modulus as we call it, increases, which is again a property of the material strength. I know you would have heard of all of these terms, and this is what we are going to do in this entire hackathon. So we are going to play around with these values.